Hello friends, in this video I'd like to solve the following problem from the Romanian International Mathematical Olympiad Team Selection Test 1987, problem number 9. We wish to prove that the following double sum, first sum goes over I from 1 to n, second one goes from j equals 1 to n, of ij, cosine of alpha I minus alpha j is always greater than or equal 0 for all real numbers alpha 1, alpha 2, and so on. It's not a difficult problem once you notice that we have a nice formula for cosine of x minus y. Cosine of x minus y is cosine of x times cosine of y plus sine of x times sine of y. And we will use it. So give this problem a try and I will see you in just a minute. Okay, so as I suggested, cosine of alpha I minus alpha j can be written as cosine of alpha I cosine of alpha j plus sine of alpha I sine of alpha j, well-known trigonometric identity. And now we can take our double sum. First sum goes from I equals 1 to n. Second one goes from j equals 1 to n. ij cosine alpha I minus alpha j. And we can write it in the following manner. Sum going from I equals 1 to n times sum going from j equals 1 to n. I cosine alpha I, j cosine alpha j is the first part. And we have also a second part. Plus sum going from 1 to n, sum going, it's horrible sigma, much better, sum going from j equals 1 to n, I sine alpha I, j sine alpha j. And now let's notice that we can write these sums in the following form, because here is I and here is term with I, so they can be put into one sum going from I equals 1 and I cosine alpha I, and terms with j can be put in another parenthesis. Sum going from j equals 1 to n, j cosine of alpha j. And we have our second sum from I equals 1 to n, I sine of alpha I. And we have our sum over j. J sine alpha j. Okay, but now let's notice that these two sums, this and that, they are, sorry, there is no square right here. My bad. These two sums are just the same. Likewise, these two sums, they are also the same. The only difference is the name of our variable of summation, but that doesn't really matter. So we can write it. We have sum going from I equals 1 to n, I cosine of alpha I squared, plus these two sums can be written, sum going from I equals 1 to n, j sine of alpha, not j but I, doesn't really matter, but let's choose I squared. And it's obviously non-negative because we have sum of two squares, obviously. And that closes our proof. Quod erat demonstrandum. Quite easily done. Thank you for watching and I will see you next time. Goodbye.